Hello. This week we'll be doing what's called proof workshop. Um, Last two times I taught the course, um, students told me that these peer reviews of proofs were the most helpful for them to learn the ins and outs of writing proofs. So I'd like to replicate that situation, even in this like remote distance learning format. So I've been brainstorming ways to make this doable on Canvas. And here's how we're gonna do it. So let me walk you through what I want you to do for this workshop. Instead of doing it all in the classroom all at once, it's gonna be broken into three different steps. Okay, so here's the PDF of the assignment description. So proof workshop will happen in three parts. So today, I want you to focus on this first part. So by midnight of Wednesday, April 22nd, so if you're watching this video on Tuesday, April 21st, then you have until the midnight of the next day to submit one draft of the claim that's made below on this PDF. What I want you to do is submit your draft of the proof typed on the discussion board on the Canvas called Proof Workshop 1. So by Wednesday night, I want everybody to submit their post. Once you submit the draft of your post on the discussion board, you'll be able to see other people's drafts of proof as well. So that's step number 2 of the proof workshop is going to be so on Thursday up until midnight on Friday. I want you to go back to the proof workshop discussion board and start reading other people's drafts of proofs. And I want you to fill out the proof rubric for at least 2 other drafts other than your own of the same theorem, and then kind of critique it from 4 points of view and say a word or two about what you like about the proof and what you change about the proof. And hopefully, if people are prioritizing to respond to proof that people haven't given replies to, then at least everybody will be covered at least once, and hopefully twice for everyone. So this will happen by Friday night. And both of these things are low stakes assignments. By that I mean, I'll give you credit not based on how good your original draft of proof was or how good your criticism was. I will be giving credit for giving an honest attempt at it. But the third part, which is going to be due by midnight on Tuesday next week, on April 28th, is that I want you to go through those the critiques of your draft of proof, and maybe you've learned by looking at other people's proofs of their drafts and their criticisms. Maybe you can write a better version of the proof by that time. So I want you to take in what you learned and rewrite the proof to the same theorem. So that will be due not on the discussion board this time, but you're going to type it up and submit it on Canvas assignment proof workshop 1 revision. So that will be the 3 steps of this proof workshop. So let's look at the claim I want you to prove in this workshop. So what you have is the triangle XYZ that is inscribed inside of this. Oh man, that's a horrible semicircle. I'm not going to even attempt to draw it. So if you inscribe a triangle inside of a semicircle in such a way that the two of the vertices of the triangle is sitting on a diameter of that semicircle, always supposed to be the center of the semicircle. So if you've drawn a triangle in this form, then it forms a right triangle. So it certainly seems plausible from this diagram that it might be a right triangle, but I want you to prove it. So, so here's what I want you to do for the first step. Right? So the first step is to write the first draft. Right? So what I want you to do first is to write down organized definitions and facts you know about triangles and circles that might be related to this problem. And because I think this is a difficult problem to tackle on your own, I think I'll get you started on this step later on in this video. But intentionally, I will leave out some definition facts you might need to prove this one, or I might give you extra definitions or extra facts that you might not need to prove it, right? So I'm going to be intentionally a little bit vague about what you need and you don't need. Once you have a list of facts and definitions, I want you to brainstorm ways to put together the facts to come up with a logical deduction of the claim. If you're not sure how to get started, and I think this is a difficult problem, so don't be discouraged if you don't know how to solve it right away. I want you to consult, there's another discussion board item called Proof Workshop 1 Brainstorm discussion board, and see if you can post some ideas on how you might tackle this problem, some facts that you think people might need, or read other people's ideas and see if you can try to form your own thoughts about what your draft is going to be. Again, I have no restrictions about what you can post there. You can, on the brainstorm discussion board, you can post what you think you're going to submit for your draft and solicit other people's ideas about, hey, I think I'm going to like use this argument, and then solicit feedback as well. So I think for this discussion board, I will try to stay hands-off. So other students can share each other's ideas and what you think is good and what you think is not enough. Once you have a version of an argument which proves this claim, I want you to type it up and post on Canvas discussion board Proof Workshop 1. This, unlike the brainstorm discussion board, the actual submission for your first draft is set up in such a way that you can't see other people's drafts until you post your draft. So it'll look like it's empty discussion board until you post it, and then you get to see other people's. But refrain from going to the second step of critiquing other people's proofs until Thursday. So everybody get a chance to post it and other people can criticize their proofs, right? In case they posted late, I don't want everybody else to have reviewed everybody else's and maybe one person stuck not being able to get reviews from other ones. Okay, so that's the general outline of what I want you to do today and maybe up until midnight or Wednesday. Let's look at the facts you might need. Okay, so here's some geometry facts that might be relevant to the problem that's posted. One is a definition of right triangle. So any triangle with one of the angles that's exactly 90 degrees, that's a right triangle. If you want to work with radians, that's perfectly fine. That would be pi over 2 radians instead of 90 degrees. Either I have no preference about using degree system or radian system. So either is okay for this problem. Another definition that might be useful is the notion of isosceles triangle. So any triangle with at least two sides of equal length. So if you can come up with a triangle where these two sides are the same length, then it's called isosceles triangle. Because we're talking about semicircle, maybe the definition of circle might be relevant. So circle is all the points that are some distance r, and this distance r is called the radius of the circle. From a particular point C, and the C is called the center of the circle. So we have a center, I think in the diagram, the center is named O, and the circle itself is all the points that are the fixed distance R away from that center. Okay. And here are some facts that might be useful. So these are facts you don't have to prove. You could just cite it and then use the result if it's helpful. So one proposition or theorem that's useful to know is that sum of all angles in a triangle is 180 degrees. So you might remember this from geometry class in high school, or maybe you've forgotten, but it might be useful. Another theorem about right triangle that might come into play is the Pythagorean theorem. So if you have right triangle ABC with the, let's say the angle ABC. So when I say the right angle ABC, starting with A, then bending at C, if this is the right angle, then the segment AC is the hypotenuse. So if you look at the length square of the two of the legs, AB squared and BC squared, and if you add those two together, then you're gonna get the hypotenuse length squared of this right triangle. So this is probably something that you're familiar with. Maybe you're more used to this formulation of it, but it's saying the exact same thing. Another theorem that might be useful is that isosceles triangle have two angles being exactly equal. So if you have isosceles triangle, which means these two sides have the same length, the angle ABC, so it's called the angle alpha, that is the exact same angle as the angle ACB. Okay. So this might be some fact that you're intimately familiar with from geometry, but that's always true for isosceles triangles. So maybe that could be useful. And some general notation about triangles that I want everybody to kind of stick with, so everybody has the same notation, is that when you talk about a triangle, you have to specify three different vertices. So you could talk about triangle ABC, and then here's one way to write that. So you write a small triangle and then write ABC, and those are the name of the three vertices of the triangle. If you're talking about like a line segment between 2 points, you usually write down the two endpoints, the name of the endpoints, and then a bar above it to indicate this is a line segment connecting those 2 points. If you want to talk about the actual length of that line segment, you might put absolute value sign to indicate the length of the line segment you're discussing. If you want to talk about the angle measure of a particular angle, so what you do is indicate the incoming line segment and outgoing line segment. So if you write ABC, the AB is the incoming line segment and BC is the outgoing line segment. And the angle is the angle between those two line segments. So when you, oops, I think this is a mistake here. This should be, the angle ABC should be angle between AB and BC. So the vertex you write down in the middle of this angle is the overlapping vertex of the two line segments. And people might use the notation arc ABC to indicate circular arcs. That goes through those 3 points. So if you write arc ABC, it's talking about this arc. Because there's a circle inside of the problem, maybe this would be useful. Okay, so these are, I think, the notation, definitions, and facts that I thought that you might use in the proof of the claim. So if you think there's something else that you think is helpful, go ahead and post those on the brainstorm discussion board. And if you think there's something that's irrelevant, you can argue why you should ignore a particular definition or a fact that I've listed. Okay, so I think I wanna end with the help of this workshop for now, but it might be good before you write down the proof or a draft of the proof to first look at the rubric that you're gonna be using to evaluate other people's proofs, because the rubric tells you how to write a good proof, right? So let me jump to the rubric before I let you go. Okay, so here's the proof rubric we're gonna be using for this workshop. The math major does have its own mathematical writing rubric ready, but for proof writing in particular, I think I want to use a slightly more simplified and adapted version of the rubric. So we're going to put 4 categories in this proof rubric, and each of the category is going to be rated out of 4 points. So when you look at other people's proofs, the best score you could give is 16 out of 16. Okay, so let's look at the 4 categories a little bit more carefully. So the first category is organization. So when I want you to write proof of the claim, I want you to restate it in terms of here's the theorem and here's the proof. Here's where the proof begins and here's where the proof ends. So that should be very clearly organized on your post of the draft of the proof. So, so theorem proof format is followed, and any necessary definitions are provided before the theorem, and the proof has a clear beginning and an end. So all three of those things are important. And if they've done that perfectly, you could assign 4, um, all the way down from, I guess you could score it 0, 1, 2, 3, or 4 here. Clarity is how clear what they're saying is. So the writing is not difficult to follow or understand. There's no extra unnecessary sentences. You're using proper mathematical notation. And I don't want you to be too harsh about getting the grammar correct if what they're saying is clear. But if it's written in such a way that it's not clear what they mean, then you should take points off of clarity as well. So you have to be able to communicate what you mean in your sentences. So clarity is part of it. So that's also going to be out of 4 points. So you want to be writing it so that the reader can understand what you mean. The next category is rigor or mathematical rigor. So this is how logically sound your argument is. So you give good points to rigor if mathematical claims that you make are all true and coherent. And each step follows logically from preceding steps. So if you can follow all the steps, that will give you a good score for rigor. And then finally, for completeness. So there's no large holes in reasoning. So it is possible that sometimes you don't need to go into every single detail, but if there are some omitted details, then it could be easily verified by the reader of the same level and background as the author. And you cite the textbook or theorems that you need to complete that proof. So when you quote a result, you tell the reader where you got that idea from. Okay. All of these 4 categories are out of 4 points each. And I want you to add it up. So if you are evaluating other people's proofs, that's where the score is going to come from. But on top of the score, I want you to write down 1 or 2 things about what you like about the proofs, so what the author has done well. Also, this is something that I haven't considered. Maybe this was good, or I like how clear you were about giving names to the variables, things that you notice that the author did well. Say here, and also tell something about how you change the proof to make it better. Right? So something that maybe like, I don't know if this sentence was necessary, or I think you should include this definition before the proof. These type of feedback. If you think you can improve a proof, I think you should say that. So say 1 or 2 things about what you would change. And this is how I want you to use the proof rubric when you do the second step of the proof workshop. Okay, so this is the version of the proof workshop we're going to try. I'm kind of making this up as we go along. The second proof workshop might be a slightly different format. Anyways, I hope it made sense, and asking questions through the discussion board or the Discord channel if you have anything. And I'll see you guys Thursday.